Hello everyone. This is the second lecture of the first chapter. In the last lecture, I described how to understand the probability and the data. We defined the structure to define the probability, and it involved something like the sample space, the experiment, the outcome, and the event. So we had to define those basic terms to make the definition of probability complete. So, and from the same framework, we can understand the data as the observations from repetitions of the experiment. So that's how we could understand the randomness, the probability, and the data. And today I'm going to show you a more realistic, a little more complicated data like this. So this is a real data, and I'm going to post the file, the data file, on Blackboard so that you can have a look and do the same thing as I do here. So it's a I'll show you. This is the data I'm showing you. So I just captured this screen, and this is what a typical data look like. Of course, it's cleaned out. So usually, when you analyze some data, at first you need to clean up the data. Like there may be a lot of errors, missing variables, missing values, or some observations that you are not interested, then you need to filter out those kind of observations. And then this is the cleaned up data ready to be analyzed. So now, and this data is from the NLSY. NLSY stands for the United States National Longitudinal Study of Youth 1997. So this data was collected since 1997. I think this data set is being collected these days. So like it's been like more than 20 years, but still it's being updated, I guess. So it's a very popular data in academia to understand how income changes, employment, education changes in your life, in your lifespan. So anyhow, let's have a look. It's easy to understand. First, the first variable A, column A has gender, which is either female or male, and second column has birth year. So the population of this data set is youth as of 1997. So the birth year is maybe between 1980 and 1984. So these are the people whom we are interested in and whom we can analyze based on using this data. So it's not everyone, but restricted set of people. And third column has race, and fourth column has region. Region is there are only 4 categories in the region: northeast, and west, south, and north central. So it's simply the region is divided simply into 4 categories. And education, 12th grade. So education means the highest grade this person completed. So 12th grade means high school graduation, and 9th grade and it does not show anything else, but 16. If you see 16th grade, that means college graduation. And marital status, intuitive, and employment status, intuitive. So employed, not in labor force, unemployed. And health insurance coverage, yes or no. So it is easy to understand what it means. So, and let's think about the underlying structure of this data, underlying randomness structure behind this data. So let me explain what happened here. NLSY is collected every year from 1997. So I think it's being updated still. And the same respondents are surveyed every year. So I say, for example, if I was interviewed last year, then they call me again every year, so that they want a updated status of mine. Like if I was employed last year, they want to see if I'm still employed or if I'll be employed next year, and how my income changed, how my education changed, like that. And attached data, the data I just showed you is from 2006 survey. I just chose, so it is surveyed every year, but I chose 2006. And the population is, the target of this this survey, this data, is those who were born between 1980 and 1984. As I said, it restricts the population to these people. And the sample size is more than 7,100 after removing missing values. So in the original data set, there are some missing values. Someone may not answer to some questions, or someone may have died, or someone may change their contacts without notification, so get lost. So there are many reasons not having the complete answers for everyone. But even after removing those incomplete answers, we still have 7,100 observations, which is pretty good. And then, okay, this is the data set. Now, what is the underlying experiment? The underlying experiment behind this data set is randomly choosing a person. So you are choosing a random person out of this population. So we have a specific population of our interest, and what you're doing, the randomness is generated from your action that chooses a random person out of the population. So so when we say, for example, education is random, then the randomness, it means that when I say from this data education is random, or when I say so what is the probability of the education is greater than 12, then you may put this question in this way: if you choose a random person out of this population, what is the probability of choosing a person with 12 years or more education? So like the randomness, the probability is coming from choosing another person. That's a simple thing. And also, what's interesting here is, so here, experiment is choosing one person, but from one person to one person, you ask 8 questions like this. What is your gender? What is your birth year? What is your race? What is your region of residence? What is your education, marital status, employment status, health coverage, health insurance coverage? So there are 8 questions, and so one experiment generates 8 observations, right? One experiment. Remember, one experiment is choosing a random person. One person is one experiment, but one person equals 8 answers, right? So when in this case, I said the sample size is 7,100. This means there are 7,100 people answered those questions. So in the end, on my Excel spreadsheet, there are 7,100 by 8 cells. So that's a typical confusion. But when I count the number of experiments or the how many times the experiments repeated, I do not count how many questions you ask, but I only count how many people you randomly choose. So because asking different questions is not random, right? So let's think about this way. So one experiment, I said one experiment is choosing a one person. So one row is one experiment, and one row has 8 observations, 8 values, 8 outcomes. So one outcome has 8 answers at the same time. So the number of columns in this structure, number of columns, is not important in analysis. But what's important for precise analysis, statistical analysis, is the number of repetitions, which is the number of rows. So okay, then let me put it the other way. Suppose that there is a data set and there is another data set, and in that data set the survey was taken on only 10 people, but from each person you asked 1,000 questions. Then what is the sample size? Still the sample size is only 10, because you only surveyed 10 people, even if you interviewed them deeply, like asking 1,000 questions, but that does not help for statistics. Maybe other social sciences not using statistical methods may like that type of data, but from the statistical viewpoint, having only 10 people is too small. Does not matter how many questions you are asking. You just need more repetitions of the experiment. So that's a very important concept in general in statistics. So and as I said, and then one column is called a variable. We are going to call a column a variable, and then when you think about a variable, you can think it as a question in a survey. In the survey data, just one question makes one variable. And if you ask more questions, you will have your data set will have more variables, which is good, but it does not affect the statistical accuracy. So theoretically, they are quite different. The number of columns, number of rows are quite different. Okay, so anyhow, here, then the next step is I said we have 7,100 people times 8 variables, which is a huge number. So it's even if I have the data, it's useless. It's not informative at all. So we have to, the first step to do is to summarize the data and see what's going on. So in the next video, I'm going to show you how to obtain probability distribution table from the dataset on Microsoft Excel. So I want you to open Excel and follow what I do. Do what I do, and it's simple. I'm going to use pivot table, just in case if you are too much familiar with pivot table, then it may be too easy for you. But if not, if you don't know what it is, it's really useful tool in Excel. So I'm going to demonstrate Excel in the next video. So see you there. Bye.